All right, ladies and gentlemen, so yesterday we looked at writing equations in y equals kx form. Today we're going to look at a different form of the equation, and that's called standard form. And standard form is when x and y are on the same side of the equation. And they look like what we have here. So ax plus by equals c. And the solution is when any ordered pair x and y makes the given sentence true. So a and b are constants, or I'm sorry, a and b are coefficients. C is a constant. But that's the way that we're going to see these looking. All right, so let's start. I'm actually going to come back to number 1. I want to go down and look at number 2 first. So down here, right, we have the linear equation, negative 50x plus y equals 15. So this is standard form. X and y are on the same side. We have a coefficient of negative 50, we have a coefficient of 1, and we have a constant of 15. Which pair of numbers make the equation true? Well, this is actually, we want to find that out. So if x equals 1, then y equals. Well, so I'm going to put 1 in for x. So I'm going to start by copying over my problem. I'm going to fill 1 in for x, so negative 50 times 1. And now I have to go through and solve this to get y by itself. So this is, again, solving those equations that we worked on earlier. So negative 50 plus y equals 15. So add 50, because it's a negative. So that means y would be 65. That means the solution to this problem, one of them, is 1, 65, because I could take and graph that. All right, let's try B. So same equation, but this time I'm going to fill in negative 2 for x. So I'm going to have negative 50 times negative 2 plus y equals 15. I have to figure out what negative 50 times 2 is, which is 100, plus y equals 15. Cancel the 100 by subtracting because it's a positive. So y is negative 85. So again, I could write that answer as a point because eventually we're going to be graphing. We've done a little bit with graphing, but that would be the point, negative 2, negative 85. All right, well, let's try this next one. Now they're telling me y, I want to figure out x. So that means I would have negative 50x plus 0 equals 15. So negative 50x equals 15. To get rid of the negative 50, I have to divide. And I'm going to do that on my calculator. So if I do if I do 15 divided by negative 50, I'm going to get negative 0.3. So as a point, this would be negative 0.3, comma 0. That's what that would be. Is the ordered pair 2, 75 a solution to the equation? So now I'm going to put in 2 and 75 and see if the problem works. This is like a check. So we're going to do negative 50 times 2 plus 75, and I want to know, does that really equal 15? Well, negative 50 times 2 is negative 100. Negative 100 plus 75 is negative 25. That does not equal 15, so that's a no. All right, let's go on. We're going to go back up. So now we're going to go through and we're going to try to write an equation here. So Emily tells you that she scored 32 points in a basketball game with only 2 and 3-point baskets. No free throws. How many of each type of basket did she score? Use the table below to organize your work. So I want to go through and I'm going to first write an equation. So x is going to be the number of 2-pointers. And y is going to be the number of 3-pointers. So my equation, right, the number of 2-pointers, x, times 2 points, 2x, plus the number of 3-pointers times how many she made, 3y, has to be our 32. All right, so that's where that equation would come from. So now I'm going to try different combinations of points to see, well, how many of each kind could she have made, right? So let's say she only made 1 2-pointer. All right, let's say that that's all she made. So this would then be 2 plus 3y equals 32. and I would have to go through and subtract. So 3y equals 30, y is 10. So if she makes 1 2-pointer, then she can make 10 3-pointers. If she makes 2 2-pointers, right, well that would mean I'd have to fill in 4 here, or 2, which would be 4. 32, so 4 plus 3y equals 32. 3y is 28. Divide by 3, she can't do that because you can't have, 3 doesn't go into 28. So that one wouldn't work. All right, but you could keep going through and trying different ones to see what combinations would work. All right, so we're going to save that part for a little bit later. Let's come over and look at another type of graph. So I want to find 5 solutions for the linear equation x plus y equals 3 and then plot them. So I'm going to have x in my table. This is where I put the equation, x plus y equals 3. And then this is where I'm going to figure out my y values. So I get to pick values for x. I have to do that. So I'm going to pick -2, -1, 0, 1, and 2. Those are the standard ones to pick. You don't always have to pick that. So now when I put them in, just like we were doing before, but now it's in chart form. So this is going to be -2 plus y equals 3. Right? To solve that, I would have to add 2 to both sides. So y would equal 5. So I would fill in 5 over here. If I put -1 in, so -1 plus y equals 3. To solve it, I would add 1 to both sides. Y is going to equal 4. 0 plus y equals 3. Well, that one, oops, that should say 3, sorry. Well, that one's pretty easy. That's a 3. And hopefully you're seeing a pattern here. So 1 plus y equals 3. Subtract 1, y is equal to 2. 2 plus y equals 3. Subtract 2, y is equal to 1. So these are now points that I can put on my graph. So this would be the point -2, 5. This would be the point -1, 4. 0, 3, 1, 2, and 2, 1. And it should make a beautiful straight line. If it does not, it means you've done something wrong. All right, number 4, we're going to do together in class tomorrow. All right, so we're going to do that one together, so don't worry about that. All right, but any questions, bring them to class, and then have a good night.